This video we're going to use the factorial notation that we looked at last video with the binomial expansion. So we're going to use it in the binomial expansion. So it's just a quick way of expanding the polynomials without using the Pascal's triangle. Okay, so I'm just going to go through examples and I'm just going to do the factorial bit on my calculator. So first up, we start off with expanding 1 plus x to the power of 10. It says give the first four terms. So we start off with 1 to the, let me change my color. 1 to the power of 10. Add, and then we use our factorial notations, 10, 1. And then it's 1 to the power of 9. And then the second term times x to the power of 1. So again, like before, the indices of the two terms will add up to the indice here. Plus, then again, factorial notation, 10 to the power of 2, add, times 1 to the power of 8 times x to the power of 2. And the last one, just do it down here, add 10 to the power of 3 times 1 to the power of 7 times x to the power of 3. Okay, so I'll just quickly do that on my calculator. So if it does ask for the full thing, you'll keep going, plus so on, so on, so on. You'll keep going, 10 to the power 10 factor 10 4, then 10 5, and while you're changing these powers, all the way till you have 1 to the power of 0, which would just be 1, and x to the power of 10 on its own. So you'll keep going, because then you'll reach a point where it says 10, 10, which will equal 1. So then you'll just be left with x to the power of 10. So that equals 1. And plus, let me just do this on my calculator. This equals times by 1. This equals 10. X. Add 45 x squared, add 120 x cubed plus dot 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 dot. Okay, but they've only asked for the first four. Okay, another example, 2xy plus 6. So again, we're going to start off with 2x to the power of 6. Add, and we start with our factorial notations, 5, 1. Oh, sorry, 2 to the power of 6, so 6, 1. Times 2x to the power of minus 5, 1. Times y to the power of 1 plus notation 6, 2. Times 2x to the power of 4 y 2, add 6, 3 to the power 2x cubed y cubed, so plus dot 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 dot, and the next, so you just keep going on, yeah. So that will equal to 64 x to the power of 6. I'll do this in my calculator quickly. 192 x times x to the power of 5 times y. I just done the 2 to the power of 5 as well and just multiplied everything. Do this in my calculator, times it by 2 to the power of 4, 240, then x to the power of 4, y to the power of 2. Add 6 times it by 2 to the power of 3. That is 160 x cubed y cubed plus dot 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 dot. It goes on. Okay, so there's going to be, it's going to keep going on until we reach y to the power 6 on its own. Okay, so next up we're going to look at example here. So again, we're just told to, so for this question we're told to find the first 4 terms and then estimate the value for 0.99 so to the power 6 using our binomial expansion. So we're going to go for 1 to the power of 6, add factorial notation, 6, 1 to the power of 5 times minus x to the power of 10. Okay, times add factorial notation 2 times 1 to the power of 4 times minus x to the power of 10 squared, add 6 to the 3, 1 cubed times minus x over 10 to the power of 3 plus dot 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 dot. So that equals 1. Add, okay, all of this in my calculator, times it by minus 6 divided by 10 minus 0.6 x, add all this in my calculator, times 1 plus x squared divided times x squared divided by 100, 0.15 x squared, and this one minus x cubed 0.02 x cubed plus dot 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 dot. Okay, so that's our expansion, binomial expansion. Now we're going to use it to estimate 0.996. So for our estimation, as you can see, they have the same power. So we go 1 minus x over 10 equals 0.99. So for x, we have minus x over 10 equals minus 0.01. Take the 1 over, and then so times it by 10, times it by minus 10. Do it quickly. X equals 0.1. I just took the minus 10 over, get 0.1. So now I'm going to substitute 0.1 into my binomial expansion. So sub, I have 0.99 sub, so so it'd be 1 minus 0.6 times 0.1, add 0.15 times 0.1, 0.1 squared minus 0.02 times 0.1, 0.1 cubed and so that means, so that equals to, do that on my calculator, 0.941. So therefore 0.99 to the power 6 is estimated to 0.941. Okay, cool. So that's how I use it for estimation.